most of our returns are in that bucket. Okay, and you can see it's roughly symmetrical. So we've got a few returns out here, and we've got a few returns out there, and you know, and most of them are in the middle. So it's roughly symmetrical, and as they say, it's shaped like a dinosaur, right? Fat in the middle, thin at the ends. There it is. So I've said nothing about that blue line. I said nothing about that blue line. And you know what? Just to, in the spirit of 1 second. Now I'm going to try discard. I'm going to try and see if I can quickly go into Excel to show you quickly what I'm trying to show you. So as I said, please bear with me. I am trying to show you, where is my database? This won't take long. I just want to make this a little bit more real. Hopefully it'll show you what I'm trying to show you. So share data. It doesn't matter. I'm just going to open a quick share share graph here. It doesn't matter what these are, and it doesn't matter what the period is. I just want to show you something. So very quickly, and I'll make this bigger in a second. Let's just go over here, and I want to show you what Sainsbury's looks like. So there we go. And here are some data that I'm going to just clear all of this. Okay, so what have I got? I have got a nice little spreadsheet here, and you can see there's 2000. The data start in November 2000, and they end 10 years later in November 2010. And if I had to draw that, I'm going to go quite quickly because I don't want to waste too much time. I want to show you what the share price looks like. That's what the share price looks like, right? Let me shrink that a little bit. There we go. That's what Sainsbury's looks like. Okay, so there we go. That's what it looks like. And you can see the different dates, and it's going up in years. So there are 10 years along here. And the share price went up and up and up here. And let me add a little major grid lines here in 2006. And then come the end of 2007, there was a massive spike down, right? This was the start of the credit crisis. Share prices of everything was going up, and then suddenly it collapsed, and so on. If I had to superimpose Barclays on here, and I can, I've deleted the data now, but it's fine. You would see that the banks fell much further, right? Because everybody's got to eat. So Sainsbury's fell. The share price was hammered, but everybody's got to eat. So for a bank, banks lost a lot more money, right? They lost, relatively speaking, banks were really hammered during the credit crisis. So that's just to show you what the prices are looking like. We're not going to use prices, as I said, we're going to be using returns. So let's quickly calculate returns. And that's just as simple as this. You just go returns, and you can ignore the first day because we can't calculate the return on the first day. So it's what the price was there. And I'll leave that formula up there for a second. It's what the price is today minus what the price was yesterday. All of that divided by what the price was yesterday. So very quickly, if that was $100 and that was 105 US dollars, it would be, you know, that that's a 5% increase. It would be 105 minus 100 divided by 100, and sure as nuts, we would get, as expected, 5%. Okay, so that is how you calculate that. That is, let's put it in percent. Sorry about that. There we go, it's 2.63%. And if I double click on this corner, I'm sure you all know that trick. Off it goes, and it calculates all the price returns. So I'm going to choose a random day on my birthday. Oh, didn't have a birthday that year. That was obviously on a weekend. You can see there's a weekend here. But on the Friday, the share lost 6%. And on the Monday, the share gained about 6%. That's just a random example. Now I want to go here, and I want to show you what do the returns look like, right? So I can do this. I can just click that over. And I really hate the way that's been done. So I'm just going to quickly format this. And we will make this into a little share, and we'll have no line, right? And I'll make these slightly smaller. Okay, so there are my returns. I'm also going to get the dates out, move them a little bit down. Labels, I'll move them low, and there we go. So you can see, let's format this axis as well. Let's make it a percent. Apologies for this, make it a percentage. And there we go. Beautiful. So there are dates along this axis over here. And on this axis, just shrink this a little bit, we have the returns, right? There we go. And again, you can see here, look at this here, this event here, that is September 11. There's 2000, there's 2001. So you can see this is towards the end of the year, and sure as nuts, there it is, September 2001. So this is 9/11, right? I don't know what this event was. This was possibly when George Bush went to war with the Middle East, right? The market got jumped around a bit. And again, you can see beautiful low returns over here, right? The market is not volatile, and then quite volatile, jumping around a bit again over here during the credit crisis. And then, of course, the sovereign crisis was happening over here. So that's a very simple example. As I say, prices, you can see what the prices look like. We looked at that. And if we move it over here, you can see what the returns look like on exactly the same scale. So that's all it is, right? Now I'm going to flip back to my slide, and I'm going to set up there we go. Okay, so hopefully you can see this now clearer. So there we go. Now we've built up our histogram, right? Forget the blue line. We've got that histogram, and we want to start making sense of this, right? And if I had shown you something like this, let me show you print options, pen. If I had shown you something like this, these are my data, and these are my axes. If I showed you, forget about this graph, just look at this part over here now, and I showed you the data looks something like this, right? This is my x-axis, my y-axis, and I showed you this, and I said, well, what? I'm sure you would agree that the best thing to do with this thing is begging you to draw a nice straight line through it, much straighter than mine. I mean, it's the best fit curve, right? We would use ordinary least squares. I'm sure you've all heard about this, but that's what we would do. I mean, you would agree it's begging for that sort of analysis. Well, I am going to say that is exactly what this histogram is begging you to do as well, right? I'm going to tell you, if the best fit curve through these histogram points, right, the top of these histogram numbers, is this blue curve over here, which is the normal distribution. Most of you will know the normal distribution inside out backwards. If you don't know the normal distribution well, please take my advice and learn it. The normal distribution is a huge part of finance. It's just a huge part, and it's not difficult. If you can add and subtract and divide, I promise you can understand the normal distribution. It's very simple. And we're going to go into it in more detail throughout the course. I'm going to be jumping backwards and forwards. But for the moment, I just want to point out this. If I counted up the percent, if this is a percentage, this is the percentage of the total along this y-axis here. And if I counted up all these little red blocks, I'm sure you would agree that the total percentage, there might be 25% of my returns are in this block, and 25% maybe there, and 22 and 16 and 14 and 6 and 3 and whatever. If I counted them all up, I'm sure you would agree that I would get 100% of my total observations, right? I'm just going to turn on the light here, right? That's 100% of my total observations fall in these red blocks. Now I come along and I say, well, I don't like that red histogrammy thing, right? It's unequal. Look at this. It's not symmetrical. It's not symmetrical over here. It's roughly symmetrical, but it's not perfectly symmetrical. I don't like that. I want to work with something simpler. And because humans are lazy, and I apologize to any finance people, statisticians, but I'm going to tell you that is the reason we use the normal distribution, because humans are lazy. And we want to work with something simpler. So we fit a normal distribution to it, right? And that's all that a normal distribution is the best fit curve through those red blocks. It's the best fit curve that we can get. It's smooth. It's got beautiful properties, right? It really has. It's got wonderful properties. It is symmetrical. It's perfectly symmetrical around that mean, that central line down here, right? It's perfectly symmetrical, right? We also know that the area under that curve represents the total probability of whatever it is that we're trying to measure, right? I'll give you more about that in a minute. We also know that the area under that curve then, just like the area under the red blocks, is 100%. It must be 100%. We also know that this never actually hits the axis, right? It's asymptotic to the axis, but let's not worry about that. That's a theoretical consideration. The area under the blue curve, like the area under the red little blocks, is 100%. It represents 100% of reality. So now we've got that. Now we can get rid of the histogram, which we're going to do in a second. We can get rid of the histogram. We never ever use histograms again. I was just trying to show you where it comes from. We will only use the normal distribution, which, remember this phrase, remember what I'm saying now. The normal distribution is a representation of reality. There is no such thing as a normal distribution on this earth. The only normal distributions that exist are in textbooks, right? But if I drew a histogram of the heights of human beings, it would look something like this, right? Some very short people, a low amount of small population of short people, a small population of tall people, maybe one really tall person over here, and then, you know, more people that are above average height, more people that are below average height, and most people, right, the bulk of people are roughly average height, whatever that is, 160 centimeters, I don't know, 170, something like that, right? But most people are average height. We could look at weights, right? There are some really thin people, there are some really fat people, and most people are of average. You know, there's some underweight people, there's some overweight people, some really overweight people, and most people are average height. We could look, but it's not going to be a perfect normal distribution. There is no such thing as a perfect normal distribution except in textbooks. But we can, because we don't have all eternity to sit and fiddle with real data, we make a proxy and we say, you know what, the normal distribution is good enough for all intents and purposes. So we use it, right? It's wrong. Everybody knows it's wrong. People write PhDs and master's theses on why it's wrong and how we can fix it. And there's 1,000 ways we can do things to the normal distribution to make it better. But that is what it is. We are lazy, and it is an approximation of reality, and it's got beautiful properties, so we can start doing things. And I'm just going to show you a couple, and I know I'm spending a lot of time on this, and we've got hundreds more slides to get through. Don't worry, we'll be finished in 3 3/4 hours, I promise. I want to show you some of the nice properties about this. If I were using the real empirical histogram, the real distribution of how those returns are distributed, right? If I was using that, I mean, you can see it's not symmetrical, it's a nightmare, right? But if I use the blue line, if I ignore these red things down, I look at this nice best fit, and I come along and I say to you, can you tell me, and oh, I don't know why I did that. What is the, and remember now I'm blowing up this area over here, the area between the two red lines and that blue line and this axis. If I said to you, what is the probability, and that now we're going to start applying this. So how do we use this? How do we use this normal distribution? What is it good for? Well, if I told you the mean and this thing called the standard deviation, don't worry what that is. If I told you the width of this thing, and I haven't told you what the width is yet. What is the width of this thing? Do we measure it here? Do we measure it at the bottom? You know, how do you measure the width of this thing? Don't worry about that for the moment, right? I'm going to come back to that because that's this wonderful measure called the standard deviation, right? Which is our measure of risk. That's where we're going. I'm trying to define risk for you, right? And I haven't done that yet, but just assume that you know that value. All I've got to do is tell you the mean of this distribution, the blue line. I've got to tell you, look, that's the middle of it. That's the mean. And I've got to tell you the width of it. That's all I have to do. 2 numbers, the mean and the standard deviation. Don't worry what the standard deviation means. It's the width of that distribution. If I tell you those 2 numbers, and I'll show this to you later, you can tell me without doing anything else and assuming that what happened in the past happens in the future. I mean, there could be an earthquake that could hit us tomorrow, right? Or another pandemic. Please God, no. But another pandemic could hit us, and these, you know, the share price could be very volatile tomorrow. But we don't live in that world, right? Of course, it could happen, but you've got to make the assumption that, well, if life carries on tomorrow, pretty much like it has carried on in the past, then we can say And if I give you the mean, which is this symbol here, mu, and I give you the width, which is that symbol there, which is sigma, of this distribution, which I will define in a minute, you can tell me, and I can say to you, if this is the mean and this is the standard deviation, please tell me what is the probability that tomorrow's return on this share that you have in front of you will be between -6 and -7. There's -6 and there's -7. What is the, in other words, what's the area under this bit of the curve here? And you'll have to trust me if you don't already. Any good statistical software calculates that for you in a second. You can calculate it very easily. I'll show you how to do it in Excel. And there you go. I've told you two numbers. I have to give you the mean and I have to give you the standard deviation of this distribution and say this is what they are. And you go and do the rest. And you can tell me what is the probability that tomorrow's return will be between this value and that value. Or you can tell me what is the probability between +2 and +6, that the return tomorrow will be in this region. You can tell me what the probability is that it'll be greater than 14%, less than -10%. Anything, any combination you can think of. All I've got to do is tell you two numbers. And hopefully you can start seeing that that is why the normal distribution is such a powerful, powerful thing. Now we go on to the normal distribution a little bit later. Okay, obviously this is not by any means the end of the normal distribution discussion. I'm just introducing it to you. And while we're still here, I'm now going to introduce risk to you because we need it for this graph. We need it for this graph. So let me tell you about risk. And I mean, this is a risk course, right? Financial risk manager. It's good that we define that right at the beginning. If I said to you, what is the width of this distribution, right? I'm sure you agree. You would, well, hopefully you will agree. You will be a bit confused because what is it? The height of this distribution here at the top, right, is 0. Sorry, not the height, the width. The width of this distribution at the top is 0. It's got no dimension. The width at the bottom here, how wide it is infinite, right? It goes from -infinity out to +infinity, so it's infinite. The width at the top here is halfway down, whatever that halfway point is, 1, 2, 3.5. It's about there. So halfway down, the width is about 4%. From 0 to about 6%. Well, about 4%. I'm sure you agree. If I went to this halfway mark here, let's say, and I drew a little dotted line down from there, I'd hit the axis there. And if I drew it down from there, I'd hit the axis there. So that's about, there's 4% there. It's about 5%. The width of this thing is about 5%. Of course, we're never going to do that, right? There are standard mathematical techniques of measuring this thing. But I'm telling you, we need a characteristic width. I need a characteristic width, which I'm going to call the standard deviation before we can carry on. So let me draw with a pen. Let me draw something else. If I went, this is now remember, this thing you've got on the screen is the distribution of these returns. But if I went and I got another share and I found that the distribution of those returns, whoa, it's very hard to draw a normal distribution, looked like that. Let's just say, I hope that most of you would agree that the little red line underneath here is much less risky than the blue line. Not because its height is so small, that's not it, but the width, the amount that it jumps around its mean. Oh, that's a terrible straight line. But the amount of variation around its mean is much smaller than the amount of variation here. So this blue one is the more risky one. I mean, I know I'm talking about stuff in your gut at this stage, but I'm trying to get you to this sort of thing. So how would you, if you were trying to, sorry, I didn't want to do that. Oh, sorry about that. See, I'm new to this technology, so let me go there. Hopefully that comes back. Yes, there we go. Okay, so you are now trying to explain to your grandparents, right? I'm sure your grandparents are very good statisticians, but if they're not, and you were trying to describe this thing to them, and you were trying to describe the width, and you know, remember that thing that I've just drawn, the red distribution. You're trying to say to them, this is more, the blue line is more risky. The blue distribution represents a more risky shares returns than the red line that I just drew on here. How would you describe that to them? And I'm sure you agree A much easier way would be to say to them, listen, the width of this blue distribution, the width here is bigger than the width of that small, the little red distribution that I drew here. So that's a good way to represent the bigger this width, whatever it is, I haven't defined it yet, whatever the width that I'm going to use of this distribution is, wherever I choose it, whatever that width is, it's bigger. If it's bigger, it means that the underlying thing that it's measuring is more risky than another one. That's what it means, right? The smaller the width of this distribution, whatever that is defined as, the less risky that thing is. And now I'm going to tell you just one thing. So that's all I'm going to tell you for the moment. That's actually, we're going to go into the normal distribution in nauseating detail later. I'm just going to say, and I'm going to say it one last time, the bigger, the wider this width, whatever it is, whether I measure at the top or halfway down or a third of the way down, whatever, the bigger the width of this distribution line, the normal distribution line, the more risky, because the more the thing jumps around, right? As I said again, if I had another little distribution over here and it just jumped around in here, it's clearly less risky. So the width of this thing represents the riskiness of that underlying thing that it's measuring. Just keep that in mind. That's the risk. We've actually defined the risk. We'll go into more detail later. Now, there was a guy, remember where we're going. We're talking here. We're talking about the mean variance framework, and we're talking about combining investments and building this thing called an efficient frontier. So once we have got, now we've got a whole lot of shares. Let's say we've got a whole lot. It doesn't matter if it's shares. It could be shares and bonds. It could be only bonds. It could be shares and bonds and something else, whatever. If you were to plot, and I'm going to skip over the slide. I'll come back to it in a second. If you were, forget about that slide as well. I'll go straight to the slide. If you plotted, remember I've got $100 in my hand, taken out of my wallet, and let's just say I've got two assets, right? Whatever they are. This is asset one. It could be a share. This could be another share, or this could be a bond, and this could be another bond, or this could be a bond, and this could be a share. It doesn't matter. There's two assets. Let's just take a simple example. Only two assets, and I put all of my money into this asset, right? Then I might land up here, because I would go back and I'd look back over the history of this share, let's say, this asset, and I could go and I could measure its return. And I could see, oh, okay, over the last year, let's say, and it's usually these are annual values. If I had bought this thing a year ago, it would have given, it's not a very good asset to have, it would have given me an annual return of 0.3%. Very terrible share. You don't want to buy this share. But I also measure, I go and I do this. I go and I check the last year, let's say, of returns of this share or asset. And I go and I calculate this. I go and I calculate all of these measures and so on. And that is what's on this axis here. I measure the risk of this asset is 3% in this example. Right? That's what it means. If I put all of my money, 100% in here, I might get that return and that risk. Now, if I take $10 out, so I've got $100, I only put $90 in here and 10% into the other share, whatever that is, right? This thing. I put 10% in here, $10, that example. Then this, and this is generally what happens. I'll show you how to build it a little bit later. I'll show you how to build this. Then I might land up here where the combination of the, because let's go straight to 100% in this asset. If I go straight in here, the return of that asset is even worse, right? This asset, if I held it over the last year, gave me a negative return. It doesn't have to be negative, but in this example it is, right? Minus 0.15%. Terrible return. You've actually lost money over the last year. But keep that in mind. And the risk of this thing is actually less. The risk of this thing, if I go and measure the standard deviation over here, the risk of it is less. So it's only about 2.7%, whereas the risk of this share or asset, whatever, is about 3.1%, right? Roughly. So now that's if I put $100 into this share, that's where I'd land up. That would be my return, and that would be my risk. And if I put $100 in there, it would be 0.32% and whatever, 3.1%. But now what if I start mixing them around? And this blue line that you can see here is called an efficient frontier. Right? When I say there, it's wrong, but it's important. There's all sorts of caveats that you can add onto this, but asset managers still use this today. It is a wonderful thing, right? You can do all sorts of wonderful things with this so-called efficient frontier. But let me explain how you get it. So that may be 100% in share A. This might be 90% in share A and 10% in share B, then 80-20, 70-30, etc. Right? However many dots there are. I think there are 10. Right? And as I mix, as I put more money into the other share, I move down this line, bing, 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 until it turns because of correlation, and I come back here, and then here I've got $100 in the other share. But that line now, it's called a frontier, and for those of you who don't know what that means, a frontier is like a barrier. It means you can't go beyond it. That's what a frontier is, right? You can't go beyond it. So no matter, for two shares, no matter what combination I chose, if I chose 36.342953% in this share and 100% minus that number I've just mentioned in this share, I couldn't land up here where the red dot is. I couldn't land up anywhere. I couldn't land up there. I couldn't land up anywhere along there. Actually, I couldn't land up anywhere except on this blue line. Right? And it's a frontier. I would land up maybe there or maybe there. I don't know. But I would land up on that line. Now the question comes, what if I've got 3 shares? What if I put together 3 shares? What does that look like?